All right. Welcome everyone to this course for tonight. So I have planned a certain range of topics going from open data through data visualization and going to geodata after that. I do like to make my talks as interactive as possible. So first of all, feel free to interrupt at any time and ask any questions. Second, I will have, so for the first part, we'll be using that computer and it's going to be fairly, so it's going to be slide driven. And at the end, time allowing, I have a lot of room with lots of demos to show you visualizations of various things. And so, yeah, if you hang on.
I'm not going to introduce you to that, bro. As you know, visualizations are the thing of the week. Did you follow the acquisition that happened? Tableau being bought. Who knows the amount?
13.6 billion.
Billion. So this is basically visualization of big data. So it feels like we are nearing some macroeconomic bubble burst. But last week Google bought Looker, and this week Salesforce bought Tableau, which was the leading, I would say, corporate data visualization tool with a paid license model, basically. But so yeah, it shows that visualization is a very hot space. And the good thing at Mathieu is he'll show you how to save money by using open source libraries, right?
That's correct.
So save 30 billion and enjoy the show tonight.
Yeah. So as I was saying, at the end, I'm going to have a few demos, especially about geodata. So do you guys can anyone maybe throw out what you hear when I say open data? What do you think that is? Do you know what that means? So open data would be mostly data that is provided with the permission for reuse, typically by either public instances, governments, or even private companies that provide some of their data for everyone to use and do whatever they want with it. So let me start. So we'll proceed as follows. I'll start with the part on data visualization first, and so a general introduction to that. I have a bunch of slides on how to actually clean your data and make it so that you can actually that it is in a suitable format to visualize. And so for that, I have really a detailed a bunch of exercises in cleaning data using a software called OpenRefine. Has anyone ever heard of OpenRefine or used OpenRefine before? No. Okay. Then we'll do a break, and then I'll move on to talk about geodata and a particular visualization library called Kepler Gl, which was open sourced a while ago by Uber, and then I'll go on with a bunch of demos about 3D stuff as well. All right, so general stuff. What do we mean by data visualization? What is it? So data visualization, it is about, it describes any attempt to help understanding the data by providing a visual representation. So that means you're really trying to so understand your data by looking at it, and instead of looking at numbers and text, you want to enhance this and somehow make it easier to grasp. Maybe even use that for decision making. And I will also add, and very importantly, and that's going to come back at the end, whenever you do anything with data, visualizing it at every part of the process, and including when you start cleaning it, doing anything with it, modeling, whatever. It's about the best way you can do to find your errors as well. So make sure that what you do makes sense. Preparing this presentation, I had prepared some data sets, made some visualizations, and at the very end, when I looked at the visualization, I found out that yes, there was some problem with the data set that I had made a mistake with, and yeah, so only at that point did I figure out I should fix that. All right, so so how is visualization used? Well, so first of all, it's easier for business people to understand large amounts of data, to make it compact, make it understandable. It's also a way to tell a story. So this is you can actually spend a lot of energy on making good visualizations by just not throwing any random chart, but really organizing it in a way that makes sense and tells a sensible story. You can really make detailed analysis, so combine, correlate, and improve the quality of your data by looking at the situation. You can figure out that there are some outliers that maybe you should restrict to certain parts of the data set. And so, yeah, and how can you, well, what are some rules of thumb to have in mind when creating good visualizations? First of all, you should try to really show the data, not just, so try to be as transparent as possible. So do try to summarize the data, but avoid distorting what the data has to say. So don't, well, yes. Well, when you get to it, you'll probably have the temptation to tell a story that you have beforehand, but let the data speak and let and just show the figures as they are, and also do have a story in mind once you communicate it to other people. So serve a reasonably clear purpose. So first of all, describe what the visualization explains. So have titles, have axes, but also yes. So don't well, you choose the graphs you show, and don't show any random graph and say, okay, here's what I plotted. But if it doesn't tell a story, you don't necessarily need to show it. And at last, encourage to compare different pieces of the data. So that will get into the demo part as well. So here's one example of an interesting visualization. Actually, so here it's about house prices, but actually it's really a visualization of noise levels around the airport. And here you get a fairly clear idea at a first glance of what's going on, namely that there's certain routes of planes landing and taking off around Zaventem, and you can definitely see very clearly where this happens. And and that article talks about the influence on house price according. Not sure if you can actually see this very clearly, but here's an interesting visualization. So this is a visualization of, so the color here that you see is the proportion of people who live in certain parts of Belgium that actually go to work in Brussels. And well, as you could expect, the closer you are to Brussels, the larger the proportion of people that go to work in Brussels. but it's also accompanied with interesting information about the traffic jams that this generates, and also the total number of people that go there. So as I was explaining, try to aim for a high level story. So you can try to try to not just do, okay, I have in my data set I have 30% of, say, male and 70% of female. You can try to really go a bit further down and try to understand a bit better what the data set can tell you. So try to find deeper insights. Try to be also creative in your visualization. Don't necessarily just use out-of-the-box tools. And also try to look for data sets. So that's a very important thing I find, is try to see what other data sets I can use. So if you work at a company, say, and then you have information about companies, well, maybe cross that with open data about companies, or about locations. So let's say you have public information about house prices, about demographics, stuff like that. So try to combine and enhance your data set, and then also try to get as much feedback as you can with respect to your visualization as well. So so this tweet is about geodata and open data. So here, so there's a play on word about the shape file, which is the typical file for geodata. So try to look for open data, and fingers crossed you'll find easy to use files, but be aware that you'll sometimes find data that's actually hard to use, such as when it's inside a PDF, or if it's just a picture, then you can't really get the data out of it. Here PDF as a publishing form of geodata, that's a bit of a shame. All right, so now I've talked a little bit about visualization. So I'm going to start with the data cleaning part. So data cleaning, what is it? Well, typically you have a data set and it's going to be very imperfect. You want to find wrong or inaccurate records in your data, so you want to find inaccurate entries and correct it. So make certain assumptions, maybe delete some parts and change its shape. There's really two parts to this. First, you look at it and then you figure out what's wrong, and you go on and try to fix it. So this can be a very manual and tedious process. This is actually, there's a well-known saying that, and you probably heard it already, but a typical part of a data science or data engineering pipeline is a lot of data cleaning. So so about data cleaning, of course, you should be wary of what it's going to have as an impact, you're going to probably lose a bit of information. You're not going to use the raw data, but you're going to make it usable, but you're going to lose a bit of information. You have to also think if what you're doing is going to have to be reused over and over again. Well, maybe think about how you're going to reproduce it next time the same analysis needs to be made. And yeah, so as to make it easy to reproduce. And that typically is much harder to really encapsulate this process as opposed to doing it just once. And this is where we come to OpenRefine. So OpenRefine, what is it? It's used to be called Google Refine, and actually before that, yeah, it was a specialized company that created this software. Then Google bought them, and then 2 years later, they actually made the software available to the community. And it's really a tool to work with messy data and try to improve the quality. So I'm not going to actually show you it live right now. I will do it during the demo part if, I will do it during the demo part. So what does it do? It try to clean the data, try to, well, it also allows to take data into various forms and transform it into other forms. And you can also plug various things in between. So you can use external data, web services, and so on. So this is what it looks like. It actually runs in your browser if you download the software and run it. It's going to open a browser. And it's a bit how it looks. So it's about really manipulating tables and trying to understand what's in it. So this is where does data cleaning fit? So this is the typical data science process, how it's typically imagined. So you start with some things that you measure, and they end up being collected in the form of raw data, and you you process it in some form, and you get a file which you end up cleaning first because it's not probably going to be usable at first. You do some exploratory data analysis, which includes certainly visualization. So as I was mentioning, you do this kind of loop in iterative fashion where you visualize all the time your data so that you understand what you're doing and improve the quality of your work. Eventually, your data sets can be considered clean enough so that you can plug it into various sorts of models and algorithms depending on what you want to do. And this will give rise to either some form of data product which feeds into some systems where you make decisions based on, or you can use them in whatever way you like, or you can really provide some reports, some visualizations. By the way, the slides are, I guess as usual, going to be available for you to review. For now, there has been no real link, I believe, but there's going to be lots of links to lots of resources afterwards. So OpenRefine is really, as I was mentioning, something that takes in a bunch of formats such as Excel files, CSVs, and XML files, RDF. So that's a bunch of fairly standard files. Can export into a kind of the same file formats, and crucially can also plug into either web services or can also fetch from some common data sources and try to enrich your data. So that's let's say the big picture of how it works. I'll leave you to have a look at the various names which are on there on your own time. So here's the part where I'm going to show you really in detail the way that you can do stuff with OpenRefine. Actually, if you want to, you feel free to open up your computer, download OpenRefine, and follow this stuff. But it's not you don't have to. It's going to be fairly clear. But you can use the slides as afterwards to really reproduce what is going to be done here. So. At the base of it, what's going to happen now, we're going to start with a data set, and then we'll clean up some inconsistencies. You'll see what it looks like. This is very common in data sets. You'll also remove unnecessary white space in some columns, and also we'll see how to split certain columns into multiple parts. So, as I was saying, here are the references where you can find the software. So it's on GitHub. You'll find there multiple downloadable files for any operating system. And here's a link to the data set. So you need the software, and you also need this data set, which contains, it's a data set about boats. So this is how it looks when you start. You have your browser, and you can, you can actually create a project. That's where you start. And you just say, okay, I want to load a file, and then you get the file that you downloaded. Typically a CSV, so a tabular file, or an Excel file, for example. And you just choose that file and go next. What's going to happen is it's going to, either tell you that the file is invalid, or it cannot understand what the file is, or it's going to show you a part of the content, so the first few lines and the first few columns. And then it's going to ask you, okay, should I create a project? And you just go yes. So a project is basically one big table, and that you want to start cleaning. And so you end up in this project interface, and this is really the main place where you do things. So you'll notice that you see very few lines. You only see 10 here. 10 lines is not the entire data set. It just means that, okay, this is just to show you what the data looks like, but it's not meant to browse through every single record, sorry. So what you can do, on the other hand, is to try to understand certain columns, and so that's what we do next is you look for a column that you find interesting. For example, so this is a data set about a bunch of boats, and there is a column called vessel type. So it's going to be a certain type of boat. And what you can do there is really, okay, I'm going to focus on that column and do what's called a facet. And this is going to tell you, here's all the possible values of that column. So you see all of these things. And you also see next to it the number of times it shows up. So barge is very common. This only happens once. There's an airplane in there. Weird stuff does happen very often in any kind of data set. So you can sort them according to occurrence, according to, well, alphabetically. And then you start looking at this and you say, okay, here I see something, I could improve this. There's bark steamer. Obviously, this is meant to represent the same thing, but they are different just because of capitalization. And so this is where you say, okay, let's fix this manually at first. So you just go on the second line maybe, and then you click on the edit button, and there you can change this to bark lowercase steamer. So you can just change this one to the same as this one. Now this actually represents only one row and one row, but actually if it were many rows, it would actually work for all at the same time. So you do it once, and it does it for all the instances. So like, for example, if I would change this bark into bark with a lowercase b, it would change all the 211 instances for which this cell has this value. So it's already pretty nice that it does these things automatically. You don't need to repeat it for every time you see the value. And then it has also a way more powerful tool, which is something that lets you cluster automatically. So here I just say, okay, take the vessel type column and cluster them into what you think looks similar. And OpenRefine is automatically going to tell you, okay, I saw these two things, they look very much the same. I saw these two, they look very similar, and so on and so on and so on. It may be more than two, and it may be just one in case there isn't a value that's not similar to anything else. So it's just looking at slight changes in spelling, or slight changing in the order of words, or in capitalization. And there's actually a bunch of methods that you can use which are more flexible or more rigid. And you can just go ahead and say, okay, well, these are definitely the same, these are definitely the same, and so on. You just check manually, and you say, okay, merge them together, and then replace them by one of these values. And you just do okay, you confirm that. And after that, this is cleaned. You don't have any more these silly changes in that column. So here, what you can do next is, okay, you'd like to even to do a bit more of a cleaning. You say, okay, I see there's this issue of uppercase and lowercase, and maybe in the future someone else is going to do another mistake. Let's put everything to lowercase. This is a very common operation, and for that reason it has, so there's you can really apply to a full column certain transformations, like making them into lowercase, or making everything uppercase, and so on. Another common operation, which I mentioned before, is getting rid of white space. So that's if you have, for example, a column which has numbers, let's say it has a year, 2018 or something, and sometimes this column contains 2018, but then there's a space afterward, and then maybe 2 or 3 spaces, and that actually, first of all, you don't see it when you look at it, just like that in the browser, and it's also going to mess up. You won't necessarily be able to figure out that this is a number, what the value of it is, and also you may have differences in matches. So it's always a good idea to get rid of white space by using that other very common transformation there. Another interesting operation that OpenRefine is good at is suppose you have a column and the content of that column is let's say it's a name of persons and it's last name comma first name, and this is one column, but you actually like to have two columns out of it. In this case, it's actually a column where you have a city, a comma, and then two letters for the state in the United States, or the country if it's in another country. And so in that case, well, you can tell OpenRefine very easily, just split that column into multiple columns, and yeah, just look for commas which are going to separate the cell into multiple parts, and you can go ahead and it's going to split that column into multiple ones. So this may look, let's say, maybe easy, maybe very manual. What is fairly powerful, for example, as opposed to working in Excel, is that you have the entire history of all the things that you've applied. So you have actually the recipe to go from your raw data to where you're at right now. And you can go back and forth into this history. You can undo things. Well, yes, you can undo that with Excel as well, but let's say this is a very, you have a clear view of what things you did, how many rows it affected, and yeah, what's the entire transformation. Now, what happens a lot as well is, okay, there's something you want to do with your data set, but it only affects a part of it. So for example, I want to remove all the rows for which I don't know, let's say, a time, or I want to change. In this case, I want to change the name of the ship. And I want to add this common abbreviation SS in front of the name of the ship, but only in case that the ship has a certain type here, schooner. So I can do that very easily as well. This is where you go back to the panel that we've seen before. You can select one specific type of vessel, and then you can type some form of formula, a quick expression here, which is just going to say, okay, take the old value, like this, and just add s.s. space in front. So that's going to change the value, and it's going to actually, as you type this formula, it's going to show you an example of what this will look like on a few examples. So these kinds of formulas, they're actually it's a certain kind of formulas that are specific to this OpenRefine. It's actually called the Google Refine expression language, but don't worry too much about it. Just look for what you need, but in this case it's fairly clear. You just take this word and then do plus value, and it's going to put the two things together. As mentioned, Google Refine does a good job at taking in data set and also exporting them. And here, one of the formats that are typical to use for tables is CSV, so comma separated values. And this is, you just need to locate that export button, and you'll be able to download the file to your computer so as to feed it to the next step in your process. So that's, let's say, a fairly quick introduction to OpenRefine. There's way more resources that you can find on the web, so just go and have a look at the slides. follow that link, and then you'll find more tutorials and other resources. And then, let's say you want to try this, but you don't know what to do with it. Well, there's a huge amount of data that's available out there, and that you can just look for and try to explore. And here are, well, there's a big list here of, of various sources of open data, among which, well, the open data portal of the European Union, where you'll find data about Europe in general. There's the US version of that, UK version. Well, let me not go through the entire set here, but I'll mention the AWS, so Amazon Web Service public data sets, which is an insanely large amount of data, including lots of satellite imagery as well. That's if you're into that kind of things. And also the Google Public Data Explorer. So there's a link which you cannot see there, but it's actually hidden behind this bar. But that link provides a way to search for open data sets. So if you have a theme in mind that you want to find data about, do try and use that tool. So yes, so there's a bunch more resources there. I'll just throw them at you like that. There's an extra tutorial there that you can go and have a look on YouTube. Here's a few visualization tools that you can use after you've cleaned your data set to have a look at if what you did makes sense. But we're going to focus on a few other ones just after that. But anyway, here are a few which are good. And then to kind of conclude this part of the course, I want to encourage you as well to have a look at especially the open data that is available in Belgium. So there's a lot of open data. Sometimes it's regional, Wallonian, from Brussels, Flanders. There's a lot of data that's about geographical information, a lot of real-time information about transportation, about, well, yes, we mentioned statistical information, demographics. Do have a look at those, and feel free to build on that. And there's this nice example which has a fairly long history of people who wanted to get a better view of how the trains were working in real time in Belgium, and this led to the birth of iRail.be, and one of the things that this website provides is an estimation of or a tool to know whether trains are busy or not, whether there's a lot of people in there in real time. So that's a fairly interesting tool. Okay, so so feel free to ask any questions, and then we'll do a quick break, and then we'll resume for the second part, including lots of demos. Yes.
But OpenDefine, is it working on the cloud? Or?
No, it's working on your machine. It's locally. So it's using the browser, but actually it's only communicating with a local program that's running. It doesn't send any. You don't need an internet connection to use it.
And is it optimized to big?
So it works. Well, I can show you afterwards. It works. So it loads stuff in memory. So it's not meant to really deal with let's say, yeah, I don't know, millions and millions of records. Maybe it's more about taking a subset of that data set, see how you should clean it, and then you try to implement that for a really large data set. But it does a good job, and actually there's quite a lot of data sets that do fit in memory. And we'll see one, for example, with fairly detailed data afterwards. That does take, yeah, it takes only a very small amount of time for OpenRefine to actually process that. So it does a decent job.
And my last question, if you have 1,000 of documents, you can do much?
Not really. So it's more about looking at one or a few particular data sets and do certain operations with them, or not that I'm aware of. So I would use more, I mean, it's more of an exploratory tool or really a very hands-on tool as well. So there are, let's say, more robust tools that really do, let's say, heavy lifting in case you have really, yeah, big needs. But yeah, so it's more of an intermediate tool. But I think we should not underestimate how often or how rare really big data sets are. So lots of, I mean, that happens to a lot of people in industry very often. Is you want to tackle a problem, and maybe you think, okay, that's going to be big data. I'm going to use fairly strong tools, but you end up with tables which are actually very small, and these kind of tools really solve all your problems without the need to go to something a bit, but okay. But yes, there's definitely larger scale stuff. So that's it for now. Okay. All right, I'm not sure if everyone's back, but it's all right. So, as planned, I'm going to start talking about actually stuff that I do from day to day. It's going to be about geodata, demoing a specific software called Kepler Gl, and a bunch of demos about geodata, for which we'll need to switch computers. So here we go. Actually, I realize as well I didn't mention anything about who I am and what I do, but actually that's my name. I'm Mathieu, and actually it's fairly fitting that I say this right now. I actually work for a company called Rock Estate, which is just based here in this building. There's 3 of us, and we do a lot of geospatial data analysis, and I'll refer to the website for more information, and I'll explain a lot of what can be done in this context. So, geospatial data analysis. What is geodata? It's anything that you can basically put on a map. So anything that has coordinates, points, lines, shapes of buildings on the ground, anything that has to do with addresses, anything that has to do with imagery as well, so taken from either planes or satellites, and also 3D information, and that's going to be part of our demo afterwards. So the situation in Belgium for geodata is somewhat complex. I mean, it's Belgium. We have one big data source for Brussels, one for Flanders, and one for Wallonia. There's actually fairly big news recently in that there's a federal coordinated resource for the addresses that just got opened a few days ago. So that's a fairly nice thing. So feel free to have a look, and any of those sites will direct you to the right place. You can find lots of data that has a geo component to it on the federal website for the Institute of Statistics, StatBel, and you can also find information about the federal cadastre. So that's information about the parcels, which is a federal thing, as opposed to buildings, which is regional competence. So what do we do with this kind of data? Well, visualizing, and that's a big theme of today. And here, maybe I can. So we could, for example, show a heat map of travel time from any point in Brussels to the city center. We can do statistics, so we can, for example, given any address, try to estimate the price of a house. Try to do image recognition tasks, such as given a parcel, decide in an automated fashion whether there is a swimming pool in this garden or not. And last but not least, you can try to find the shape of buildings. So try to, for example, determine which roofs are flat and which are not. So here's a short, or not so short, list of open source software that typically deal with geodata. So QGIS is an open source software which does the most usual things you can do: manipulate maps, shapes, addresses, and so on. ArcGIS is its, in a sense, proprietary equivalent. You have lots of web components, web frameworks to put stuff on maps. So leaflet and open layers being the most well-known. Mapbox and Cesium are also very big. You can, if you want to do statistics or geo-related statistics, then typically R and Python have large ecosystems to handle geodata. And if you are into databases, well, most databases will have some form of handling geodata, namely you will have an extension that instead of having columns which are integers, numbers, text, you can have columns which are shapes, and that's and you can have indices as well, spatial indices. So the most popular in the geo world is using Postgres with the PostGIS extension.
I have a question?
Yes.
Sorry.
Yeah. No worries.
I just have a question about like geodata.
Yes.
Rather data scraping. What's the position of data scraping? So just very briefly, I have to scrape all the tennis courts in the world, right? There's sites that list tennis courts.
Mm-hmm.
Is that something that's kind of not really legal to web scrape stuff?
Yes. Okay, that's a very. I'm not the. I mean, okay. I'm not a lawyer, but so you typically. There's lots of ways to go about it. It depends a lot on the source of where the data comes that you're getting your data from. Typically, if you want a fairly decent job at that kind of activities, just looking at the data that is available on OpenStreetMap is a good start. OpenStreetMap has lots of people taking a lot of time to tag lots of stuff in their neighborhood. And they include, I mean, it includes swimming pools in gardens, private swimming pools, tennis courts, yes, whatever. So I would start with that for instead of looking for lots of various sources for various places. That's yeah. I mean, of course, it's not perfect. It's not exhaustive in any way, but it's and also it's kind of, I mean, it's global in the sense that, yeah, I mean, what you'll do, it's going to work worldwide wherever people have taken the time to tag.
So OpenStreetMap.
OpenStreetMap, yes. And that is a data set that is really made for reuse, that has a license that you can do what you want with it. I mean, there are some caveats, but it's mostly you have to attribute the fact that you've used their data. So that's about it. Yes, so a few words about geoformats. So just as for tabular data, you'll find lots of Excel files, CSVs, and others. Well, you have specific formats that have shapes in them. So you'll have either shapefiles, GeoJSON, or GeoPackage files. These are specific names to say, okay, there's somewhere a point on a map or a polygon. But you can also actually do things in a very low-tech fashion if you want, with just simple CSVs, and you have columns which have the geo component in them, either in the form of, for example, a latitude and a longitude. So that's just two numbers, and they correspond to a position on Earth. Or if it's not a point, but more of a shape, a line, a polygon, something like that, then there's actually a standard way of representing shapes in a text format. And that's called a well-known text format. There's a binary version of it, but don't worry about it. Anyway, this tells you, okay, this is actually a polygon with 1, 2, 3, 4, 5 vertices, but actually this is probably the same as this one. So yeah, no. Anyway, so it's something you're supposed to be just connecting the dots, and that's a representation of that shape. And So that's so you can actually, you don't need to know about these files. You can just handle regular CSVs with one column which has a text field which is going to represent your shape, and that's what we'll be doing. Just be aware that this format, well, here it uses regular latitude and longitude, but there are lots of others coordinate systems. They're called also projections. And this is, the reason for that is because with these numbers, it's hard to compute actual distances. Well, you're going to have to use a very complicated formula. But if you use, for example, a special coordinates, there's a special coordinate system for Belgium. And in Belgium, so this coordinate system has X and Y. What's going on? Okay. Has coordinates such as when you measure the distance between 2 points, it's actually a distance in meters. So it's you can really say straight away by looking at the coordinates of 2 points, okay, they're 1.5 kilometers apart or something like that. So it's much easier to compute lengths, areas, and so on. Yes.
What's that called?
Coordinates, yes, coordinate systems, yes.
And it's different by country?
So it's just a convention. So there's lots of tools to just go from one system to another, and you can always kind of pass through the standard latitude longitude. It just has this. So it's fairly standard, but sometimes when you want to compute actually distances, then you need to go through something else. That's all. But yeah, and sometimes you'll find, especially for example on the official Belgian website, they will provide all the geodata in the Belgian coordinate systems and not in the latitude longitude. So you'll see numbers such as 150,000 for the X component and 210,000 for the Y component. It doesn't make sense for latitude and longitude, which are just angles from 0 to 180 degrees or minus 90 to plus 90. So yeah, so these are just not the same numbers. You need to translate them with projection libraries. So today, what we want to do is use a tool called Kepler.gl, which, as I mentioned, was open sourced by Uber. And it's a very nice tool to visualize anything that has, that goes on a map, and it's fairly efficient at doing so. And in our case, what we'll do is we'll look at stuff that is linked with municipalities or statistical sectors, statistical neighborhoods on a map. So if you end up having any data set that's telling you any number related to either a municipality or a statistical sector, then this is going to be a concrete recipe on how to view this on a map with colors, and then you'll see exactly the outcome. And so what you need to do that, you need to create one CSV with both the data that you want to visualize and the shapes of those things, the shapes of municipalities or the shapes of statistical neighborhoods. You'll see right afterwards how it looks. So just a big short reminder about what you can expect in terms of shapes in Belgium. So there are official shapes for the 3 regions. For all the provinces, these provinces are split into districts, but that's not very well known. What's more well known is municipalities. There are 589 of them. And these municipalities are even split further into very small, or they vary in size, but there's 19,000 and something statistical sector, so almost 20,000 in Belgium. So those are, you have to imagine, so that's on average, less than 1,000 person within one statistical sector. So that's fairly small region. And there's lots of, well, they're called like that because they're meant to compute statistical numbers at a fairly granular level. And so you'll typically find granularities at these two levels for data sets. Yes?
Out of curiosity, are those all nested? In other words,
Yes, they are nested. Yes, yes. So
no overlapping?
no. So really, a municipality is just a combination of a bunch of statistical sectors and so on. Yes. Actually, it works in an even clearer fashion. So there are certain codes. So each of those have a code, have a string attached to it. For the municipalities, it's 5 characters, and for the statistical sectors, it's 9. And the 5 first characters are just the corresponding character of the municipality it's in. So that's a way, if you only have the statistical sectors, well, then you just combine all of those that start with that number to get the municipality that contains it. So that's the way it works. These are really characters and not I mean, those may look like numbers, but do treat them as characters. They can contain letters, they can contain dashes somewhere. If you see that it ends with a ZZZ, that's 4 Z's. That's unknown, or you don't know where it is within the municipality. And then one other thing that's a bit surprising, you might wonder, okay, why do I have to deal with this 5 character thingy instead of postal codes? Postal codes, I can figure out from an address. That's very in wide use. The thing is, postal codes are exactly for what it says for the postal services. And the postal services, they have decided how they work. They are kind of related with municipalities, but not necessarily. So you may have part of a street that's, so there is no official boundaries for postal codes. So you can try to find some on your own by looking at the list of addresses, looking at which addresses are within which postal code, and try to draw shapes on the map, but there is no official shape. So be aware of that, that you may have to go through a process. If you only have addresses and you want to plot stuff on a map, you may have to find a location for each address and then figure out in which statistical sector or municipality it falls in.
Is that the case for most countries around the world?
No. I think there. So, for example, I think the UK, they have larger postal codes, but which go to a fairly deep level of detail, and that number is associated to a shape. That's it. So that's way simpler in that sense. So I think. So. I mean, I'm not an expert, but I think that's the case. And also, again, a Belgian thing that on the 1st of January 2019, some of those there was a fusion of a bunch of municipalities in Flanders. And so they changed some codes, they changed some street names, and they also changed some codes in Wallonia, even though there was no merging of municipalities. Who knows why? But anyway, be aware that these things are not set in stone. They change over time, very rarely, but it just happened in January. All right, so so here's what I propose that we do. So we download a file that's going to contain. So these are 3 files so the links are in the slides. You can download those files, and they contain basically the codes, either 5 or 9 character codes, and the associated shape. So that's all there is. And what I propose that we do is we look for an interesting data set that has numbers, so statistical figures, demographics, corresponding to those 5 or 9 character codes, and then link this to the shapes and put this on a map. That's the story. That's what I want to show how to do. And more precisely, what we'll do. So we'll start with this sectors.csv file, and then we'll use a file that I prepared, which is called census 2011 clean.csv. As the name implies, it's not straight out of the official statistical office website. It has been cleaned in a way that it really has, for each statistical sector, it has a bunch of numbers, which is the average age, the average education level, average, what was there? Anyway, just proportion of male versus female, something about the nationality of people living in that area. So a bunch of numbers, and also just the total population within each statistical sector. And so here is the entire recipe that you need to combine those two things in OpenRefine. You just need to do one thing. Well, you need to open both of those in OpenRefine and have them as projects. And you need basically to take the column in your file with the numbers. So from the census, you take the column that has the statistical sector column, and you're going to use it to create a new column which is going to contain the shape, the geometry. And and then there's this formula here which tells it to, okay, take this statistical sector column, use use the sectors project, so this other file that you have downloaded, and look for the sector code, and using that link, sector code, get the geometry out of it. And it's going to basically add a new column which has this text with it. Export the result as a new CSV, and drag and drop it into the Kepler Gl website and explore the data. So that's it for the slides. Now I will switch computers, and I'll show you in practice how this works and what you can see. All right. So maybe we need to bypass the splitter and start with that. Yeah, that one. I can plug it. Okay, all right. There we go. All right. Let me just try to figure out. Somehow I don't see the same thing here, so one moment until I get, okay, there we go. That's better. Okay, so I'm just gonna put back the slides, but, so that was our plan. Let's do that actually. So this is OpenRefine working on my laptop. It's not running in, so let me just go to OpenRefine. Okay, so here I have a bunch of projects. I have, let me get rid of this one so I don't have, so I have the sectors. Sectors, it's just this, this table which contains geographical shapes. So it has a sector code, sector name that we're not going to use, and it has a geometry column which contains lots of coordinates, and that's for every single statistical sector. And this is...
So a question on that. That's the shape?
Yes.
You connect many...
Yes, you'll see the results once we visualize it, yes.
Shape, okay.
Yeah, the shape of the sector. And so I'm going to now start again and do exactly what I said I would do. So let me browse and get this CSV file with the numbers I want to show. Okay, this is what it looks like. You have a statistical sector. You have the code, which is going to be our link with the shapes. And then you have the numbers that we want to plot. So mean age, don't worry about the smooth columns. Nationality proportion, so which proportion is Belgian with that statistical sector, which proportion is female, and the educational level, which is a number from 0 to 2, 0 being before high school, 1 is having a high school degree, and then 2 is having some sort of university degree. And then the total population as well. Okay, so that's our data set. So we use this, so we create the project. That's so basically OpenRefine is loading everything up in memory now. And now I can use this statistical sector column and use it to add a column based on that one. Okay, and I'm going to add a column which actually should, so that Kepler Gl understands what it is, it should end with _WKT, so well-known text. It's going to tell that this is the column that has the geographical information. And I just input this formula here, which is looking up the geographical information in the other data set. And I see directly that, okay, based on this column, it has fetched this, which really makes sense. That's what I'm expecting. So I go OK, compute this, and it's taking a few seconds for a data set that's, I mean, the CSV is about 100 megabytes, so that's not that small, and it's mostly that text column. So, yeah.
Isn't that just like a lookup?
It's exactly a lookup. It's exactly a lookup. Yeah, yeah, yeah. That's yeah, that's yeah, exactly. Or a join if you're database oriented. So there we go. We just export this into CSV. All right. That's going to okay. There you go. So I should have somewhere downloads. There we go. Yes, that's the new one. Sorry about the mess up. So here I have my file. I just drag and drop it. And so here I just went to Kepler Gl/demo. And this, as you'll see mentioned on the website, it's just, it's an application that runs on your browser, so it's all JavaScript, if you know what that means, but it's not going to send your data away from your computer. From now on, I might as well just disconnect from the internet. Everything is going to work fine. So it's all running just on my laptop here, which is fairly extraordinary, if you ask me. And so here, we just drag and drop this file here, this CSV. It's going to take a bit, not that long, but it's probably going to warn me also that it's actually computing fairly heavily something. Yes. Slowing down your browser. Yes. That's expected because there's 20,000 complicated shapes to plot on Belgium. So those are the shapes. And you can see that the application is actually very smooth. So that's really a very nice thing of Kepler, that you get this visualization. So first of all, let me see what I can see on my tooltip here. I can actually go and see which columns I want and don't want. I don't want the smooth versions, which I told you to ignore. On the other hand, I want to see mean age, nationality proportion, female proportion, education level, and population, plus the statistical sector, the code itself. Here, I'm just going to have the label pop up over the, so we can really see what's where. And on the left here, I have really the control over what I show, because here, all we are seeing at the moment is those shapes. Okay, fine, there's lots of them, but they're all the same color. It's not that interesting, okay? So what we want to see is really those numbers. So I'm going to have a look at this layer, which comes from my CSV. It automatically detected that these are actually polygons, not lines, not points. I'm going to remove the borders because I don't need, and I can change the color to not just be this one shade of blue. I can, for example, take the population. And here I see which statistical sectors have more or less people. So if I, let's say, zoom in over Brussels, well, I see that it's fairly yellow, so there's lots of people, except in the Forêt-Soigne. And you can see that Flanders is way more populated than Wallonia, which is indeed the case. If you remove Brussels from Belgium, there's twice as many Flemish than French-speaking people. And you can see that there's basically, in Wallonia, there's a lot of people on that belt from Liège to Namur, Charleroi and Mons. And besides that, there's not much else. But that's just the population. We can have a look at the mean age. So you can see, in principle, older and younger areas. If I can take the smooth version of it. Now you don't necessarily see that much because it's not that clear. The trend is not very clear. That does happen. There's not that much of a story to tell about this. It depends a lot on from one neighborhood to the next. So it's not a very large-scale thing. Same thing for the proportion of female. There's about 50-50, and sometimes it's 45-55, but that's not very relevant. On the other hand, if you look at number of people who are Belgian versus non-Belgian, well, you can see that basically for big cities, you have lots of non-Belgian residents, which is probably to be expected. And this is really a way to visualize this, and it's very clear, right? You really see the big cities, Antwerp, Ghent, and so on. And then if you look at the education level, it's really another picture. You do see trends, but it's really, I mean, yeah, I guess in Brussels you do have really disfavored areas versus, I guess, yeah. Yes.
So when they calculate this, I mean, they're looking at people's residences, not
yes.
places, right?
No, indeed.
Brussels is empty, or not empty. I think you showed population that was strange. There was
If you want to see, well, so okay, so now the thing is, and that's an important thing to, when you look at population, what's important to understand is that these are really not of equal size. It's not a measure of density, it's just the raw population. So if you look at a very small, I mean, this number, so over here I have a small area with 1,000 people, and then I have a large area with about 3 times as many people, but it's way bigger. So basically, this is less dense, and so I actually should have computed another metric, which is the density, and maybe density would have been more relevant to show on a map. Yeah. So this is yeah. So one more thing I want to show about Kepler.gl, which is that you can also use a measure of height. So you can basically plot a height over every shape in here, and you can have the height depend on what you want. So let me put the height at the population. So you'll see in one moment, and then I'm going to put back something else, such as whatever, this. Now let's see. So you can actually view this in 3D and make the height bigger. So here you can now see not only the color represents the metric that you are looking at, but the height represents how many people are concerned by that metric. And so this allows you to really understand a bit better what you're talking about, right? So, yes.
I have a question. If you want, now you're really happy with this graph and you want to give it to a friend or a colleague, so you can send it by email?
Yes, so assuming you can put your CSV in a publicly available or web accessible place, there's a way to enlarge this URL so that it's automatically going to fetch that CSV and load it for the person, and you can share the URL with with someone else.
Store the CSV somewhere?
Yes, you have to store it in a, or you'll tell them, okay, here it is in attachment, drag and drop it, and then do these manipulations to see exactly the same thing I see. It's not quite meant to, I mean, it's ongoing progress to really have this as a good tool to really share existing graphs. But it's an extremely powerful tool to at least start visualizing what you have and
when you share it, is it like this? Or they have to,
right, so I think they are in the process of recording all the parameters that describe this exact visualization. So it's an ongoing project. I don't think today that you can say, okay, it was this metric that was selected for the color and this one for the height. Yeah, so it could be, exactly. And then I think that's part of the plan, but I'm not sure it's already implemented. But yeah. All right, so yes?
So the tool is meant to visualize information that is loaded in a file.
Yes.
It doesn't have any type of data source different than file-based.
No, indeed. It's only meant to be, yeah, so if I reload this page, it's actually it's a bit picky on the format. It's only accepting CSVs, JSON and GeoJSON, but anyway, so basically CSV kind of format, which is not the most efficient either. So if you really want to have an application that's used by lots of people, that's not the tool you're going to use. You're going to have a full web page with a more standard format. This is more for exploration, but I mean, if you want something that's connected to a database that updates, that whatever, then this is not. I don't recommend that tool for that.
It's for static data.
Yeah, yeah. I mean, yeah, exactly.
Have an evolution of data over time. I don't see.
Yeah, indeed. I mean, in principle, everything can be done. I mean, the thing is, it's all open source, and you could try messing around, removing stuff, updating, whatever. But that's not exactly, I think, that's not the use case they really have in mind right now. But on the other hand, what's very powerful is I just loaded up a CSV with 20,000 polygons in there. And that's about as much as I can think I would need for and so even I have tried, and I can show you if I have a bit of time afterwards. I have loaded in this same application CSVs with more than 1 million addresses, and it was handling this fine, and I could just zoom in and out fairly smoothly. So it's actually very good at not needing to do the database game of just finding an area and so it's actually, and the way it does that is by using basically my graphics card and doing.
About mobile interface, or is just?
It's a good question. I haven't tried it on mobile. I mean, it's gonna heat up your phone a bit. Yes.
So this tool would work with any CSV file with two columns of data. Some quantitative data linked to a geolocation.
Yeah, for example, so you can put stuff with so instead of linking it to shapes, you could link stuff to dots, and then it actually has built-in aggregation of those dots, and you can have hex plots. I mean, have a look at the sample page. It can be trips as well, so starting points and ending points. So a CSV with two pairs of latitudes and longitudes. It can be, yeah, so this is a typical thing where you have lots of dots and you aggregate them over certain areas. So yeah, it's really fun stuff. And it's fairly quick results. So and of course don't do this if you really don't care about the geo aspect of things, but otherwise have a try at this. I mean, it took me 5 minutes to combine those CSVs together, so I'm actually sweeping under the rug the fact that I had to clean that CSV in the first place in order to have exactly one row per statistical sector, which is not the way.
The cleaning piece.
Yes.
Are there tools that can help you clean it?
So OpenRefine does somewhat of a decent job at that, but you still need to understand what you're doing. So for example, so let me show you the raw file that I had to start with. It looks like this. So you have you have statistical sectors. Wait. So that's not even the table I want to see. Well, yes. So per statistical sector, you actually have a bunch of columns which are counts of people in various combinations of situations, so with a certain education level, a certain gender, and a certain age, I think here. And so you need to basically reshape this so that it's actually an average of whatever quantity you're looking at. For example, the average gender, so whether it's, this is not going to be, if you just take one column, it's not going to be interesting. Figure out per statistical sector how many men with a higher education which are Belgian, that's not what you're looking for. So you need to do ratios of columns, sums, and averages and stuff like that. It's not.
That's not really cleaning.
No, I mean it's a bit. No, it's not exact. I mean, no. It's more reshaping and a bit statistical flavor. Yes, but.
One thing I noticed is the street address.
Yes.
Sometimes the number of the streets is inside the street address and outside. Is that an example?
Yes. So that's so really cleaning addresses is something that we're spending a lot of time on. It's hard, and it's because indeed street addresses are a very messy data source because Well, up until a few days ago, there was no official source of addresses in Belgium that you could download and make sure that you're conformed to. And so that basically meant every company, every bank, every whatever was just actually finding a supplier of some semi-official data source, which there were plenty of, and they had different data sources. And so it creates a big mess, which only now is starting to slowly getting standardized, and hopefully at some point we'll get a situation that's a bit saner, although it will never be super sane because you will still be writing, handwriting addresses, and you will still be using abbreviations for AV dot instead of avenue or whatever to write addresses. So it's a constant source of, indeed, there's a lot of fuzzy string things that need to be going on in addresses. Yeah.
I noticed that, especially in Brussels, some people, some addresses say more Brussels, some say Etterbeek.
Yep, indeed.
That's part of the cleaning process, right?
Yes, so in fact, my 2 cents here is that I would just use a postal code and not worry about whatever's written next to it. So forget about...
So the postal code is not relevant to the municipality.
Well, no, but it's going to be a unique identifier for the address. So with that, you're going to be able to know it's precisely that street at that location, and then you look up the shape to see where it falls in. Okay. I mean, there are ways to do that. I mean, you can use geolocation APIs from Google or whatever other services that you send an address, they give you latitude and longitude, and then you can do the end of the job. All right. I'm kind of aiming at ending at 8:45. Is that okay for you guys, or are you expecting less more? Is that okay? So I have more demos for you of a bit unrelated stuff, but it's 3D information, and I find it, well, super thrilling, so I just want to share this with you. It's more advanced stuff. You could just stop listening to me and just look at what's going on. That's fine. If there's stuff you don't understand, but you do want to understand, please ask questions. So what I want to show you here is a very interesting data set, which, at least in Flanders, is completely open data. And it's so-called Lidar data set. So Lidar is a technology which, so what happened here is that each region each region has flown over the entire region with plane, going back and forth, and instead of taking pictures, which is something they do every year, this time they were sending a special light beam and computing the time that the light beam was going back to the plane, which enables them to measure a distance. And so that enables them to compute what is called a point cloud, so just points in space. And this is a visualization of this point cloud data set. So let me zoom in somewhere. Well, let me try to find Brussels. So here I have in my browser lots of points. And the internet is a bit slow, but that's okay.
But
yes?
Is that just altitude above sea level?
It's measuring altitude. Well, I mean, you have let's say X, Y, and Z. You have latitude, longitude, and elevation. So you have let's say a point in space. Let me see if can I? Is it okay? Yeah, thanks. All right. Let me try and reload. Oops. Let me shut off my Wi-Fi and see whether this works.
But in this example, what's the application? It's
It'll be there right afterwards. So I'll just show you the data and then tell you what we do with it. Sorry about that. Let's see. It's not working yet. Okay, let's turn this back on. All right. If not, it's not the end of the world. But let's see. So I'm going to refresh this page and cross my yes. I think this is gonna work now. Okay, so the colors changed, but never mind that. Yes, so now it's working. By experience, I know this is Brussels. I mean, you can probably see it now. You kind of see the streets. I guess I can try and see where we're at exactly now. It's about here. This is the metro line, and I think we're about here somewhere. So the interesting thing is it's indeed a 3D data set, which covers the entire of Belgium. And you can kind of, let's see, which building exactly are we in? It's actually this one. So here I could kind of go where we are and kind of see what I'm supposed to see by looking out the window, something like that. Anyway, so yes, so that's an interesting data set, and it works extremely fluidly. So the data set itself is open. The visualization is something we put together. I mean, the tool is an open source tool, but you do need to crunch a bit the data in order to make it streamable to your browser. It's, I mean, there's some work to do there, but it's nothing really essential. I mean, there's a tutorial to tell you how to do that. And you have to crunch 2.7 terabytes of data, which is compressed. So there's a lot of stuff to do, but it's not. There's nothing really fancy that we did so far. We are just displaying the raw data. So that's to tell you what the raw data looks like, and it's points in space. It happens that they have a color, but actually it's a color that they kind of inferred from pictures that they took at another point in time, so it's actually not perfect. You can see here that for some weird reason the brown is not, the light brown and the dark brown are not stopping at the edge of the roof, and that's because of perspective effects of the images. So it's an imperfection of their coloring scheme, which means don't trust too much the color, although it's somewhat accurate. So Google Earth has some, you can view 3D, you can view buildings in 3D. In Belgium, it's mostly in some big cities. It's not everywhere at all. The thing is, they do it in a different way. They don't use Lidar for this. They use very precise satellite images, and they kind of infer the 3D information from that, which costs them a lot of money as well, because they have to actually source these images, and so they, yeah, I mean, I don't think they buy the data set, or they don't make it available for every place on Earth. No. Yeah, this is raw data, and that's measured by a sensor as is. So that's another interesting feature. I don't know if I can show it to you, but you'll see that it actually also goes between brackets beneath trees, because you should think of the light ray as a beam, and if there's a leaf in front, there's part of the beam that's going to reflect on the leaf, and then part which is going to go to the ground and reflect. So you'll see both places, and you kind of see underneath the trees, which is useful to get an idea of the shape of the ground in the forest, for example. So that's a very interesting data set. Unfortunately, it's a lot of time to deal with this kind of data set. I don't think you can really do this in your spare time, but it's still a lot of fun. And it's everywhere in the country. In the Wallonia data set is of a different resolution. It's only 1 point per square meter as opposed to 16 points per square meter. In Flanders, that's just the way things are.
Why can't you see people if they're being hit like leaves?
You can.
You can?
I suppose if you were, so that's a data, so for Flanders it took them 3 years to acquire this data set. And I suppose if you were standing there at the moment that they flew over that region with the plane, there would be a few points that would correspond to your body being there. You can definitely see cars, that's fairly clear. You see the shape of cars. You don't see the shape of people, not with 16 points per square meter. That's a few points for me. That's not a lot to say, you know, where am I looking at? I don't know. Yeah.
There is a lot of black area on the map.
Black, so here we have subsetted the data to only points that are close to buildings. We don't care about, or for us, I mean, the data is available, but we have subsetted it for also to ease the task on the browser to not handle all those points everywhere. And so you don't see points where there is no building.
You don't see like a lake? Or
Yeah, exactly. I mean, these points, so, okay, then there's the question of whether you would actually get points on a lake because the light wouldn't go back to the sensor, it will reflect. So actually water tends to not generate points with respect to this technique. But yeah, that's a kind of besides the point.
Is views available online?
No, that's, I mean, if you go to this website, you'll be greeted with a message telling you should log in on our website. So it's, I mean, it's an internal tool for us. But I mean, it's basically just to view the raw data. The raw data itself is available. So, yeah, I mean, we could share it, but it's not, I mean, it's also not our core business or anything. So, I mean, not the visualization itself.
Basically, there are the only concept that we have points.
It's only points.
We don't have the concept of buildings or
Exactly.
the
Exactly.
sector that we had before with the cities. It's only points,
Only points.
and we see the display. This looks like a building, but that's it.
Exactly. Exactly. And that's the very interesting part about it. And that's exactly what we do, or part of what we do is to try to get to interpret this data and to make sense out of it. So we already know from another data source what the shape of the buildings on the ground is. So we know there is supposed to be a building. We can look at all the points that are above it, in a sense. But now, okay, try to filter out the data that are from a tree above the roof to just the points on the roof. And maybe there was no building at that time because now we know there is a shape, but actually at that, when they captured it in 2013, 2015, there was no building. And so you have to figure out that this is actually the ground. And what we do, in very briefly, is to generate 3D models of buildings. So kind of fill in the dots if you want. Really do something that's really interpretable and be able to say, okay, that house has a roof with, yeah, okay, I mean, the metrics are a bit nonsensical, but it's, you know, it has that many parts of the roof, it's that slope, and that orientation, and you could fit that many solar panels on it, maybe, something like that. Also, we compute a volume for every building, stuff like that. So that's, in very short, part of what we do is for every address, we now have such a 3D model of the building. And I could show you.
On that, is that all within GDPR?
Yes. So, well, the data itself is publicly available and provided with a license for reuse by the government. So in a sense, if you don't like that this data is available, you should basically contact the government and say, please erase that part of the data, or something like that.
For example, if you wanted to find out who has a pool in the backyard,
Yes.
you could actually find.
So yeah, so you can you can do that. Again, it's not that it's, I mean, it is personal data in the sense of GDPR. It is personal. I mean, any image. I mean, your address is personal, but we're not matching it with personal data. We're only saying stuff that doesn't change when the owner changes, basically. So if you want to see it like that, we only say stuff about the building, and so only objective stuff that is relevant to, you know, how much should you insure this house for? Because there's a swimming pool, so you should insure the swimming pool, or the house is that big and so it has that much risk of burning down, or something like that. So that's what we do, but we don't start inferring, you know, trying to figure out. We don't link to the demographics. We don't link to even statistically anonymized data about people. We only deal with data about buildings, and yeah. So in that sense, it is, yes.
I mean, of course, some bank or some
Yes.
state, if they have the people who live in each address, they could say, I want to tax everyone who has a pool.
Yeah.
They're going to ask you,
Yeah.
where are the pools, and then who owns those houses?
Yes.
How to contact them.
Yeah. So the thing is, for example, for an insurer, what they used to do is to basically, it was part of the questionnaire you would fill in when you would get an insurance. And the only thing that this allows you is to kind of pre-fill that questionnaire with, we think that it's the case that you have or don't have one, and you still should fix it if it's not correct. So that's about as far as this goes in terms of that process. It's kind of still the same information, except that it's pre-filled, easier to use, can be used online and in real time. That's kind of the upside. I have an extra demo to show, but I'm kind of running towards the end of the time, so it's a bit up to you. Maybe I can take questions if there are more, and then for whoever wants to say 5 to 10 more minutes, I can show another thing. And whoever else would like to leave can leave. How does that sound? Questions first. No extra questions about the stuff for today. So again, I can show a quick demo of how we get around to building those models and how we do this exact thing of taking this set of points that has no information whatsoever, and how do we figure out what's a tree, what's a building, what does the building look like. So if you want to see that, that's going to be in the next 10 minutes. And again, I'm not going to be offended if you want to just leave now. Feel free to leave. So this is a presentation I gave a few times already. Don't worry about the code. I'm just going to take, so here is a map. This is actually the campus of the Free University of Brussels. And I'm going to plot a region, a polygon on this map. And out of this, I'm going to take all the points which are above, sitting above this polygon. So that takes a few seconds. And yes, there we go, 12 seconds. There are, there's actually it's not the full data set, it's just a resolution of 4 points per square meter. That's 400,000 points for that particular region. And the fun stuff is that we get to visualize it. So we get to look at this data point, this data set. This is what it looks like. And it is lots and lots and lots of points, and you see that they're all red. There's no interesting information about them so far. They're just all the same. They just float in space. Go ahead and do something interesting with it. That's the challenge. Actually, I'm lying. The data set that the government provides has already done a segmentation of what is ground points and non-ground points. The way they do it is with an algorithm. They look at which are the points which are the lowest locally and try to extend this without going too big of a slope. And so you can already picture this by putting two colors. Gray is the ground points, red is the non-ground points. Okay, so instead of putting points on the surface, I'm just going to put a flat thing because it's really flat. So I replace this with a flat area. Sorry about the resolution. And then what I'm going to do is look for every point, look at the points around it, and does it look flat or does it look fluffy? Does it look like there's points around it everywhere? And I'm going to assign a number from 0 to 1, the fluffiness of the point, or flatness if you want. And you can see by visualizing, and that's crucial, I kind of had various measures of flatness, and I chose the one that fitted best my needs by looking at what it gave on this data set, and I say, okay, it seems to do a good job of separating buildings from trees. And so, I mean, it's a simple metric, but and so I kind of selected a threshold, and I said, okay, everything that's above, that's supposed to be a tree point, and then everything that's below, that's a building point. I hide all the buildings, and now I start to look at the trees and try to see, okay, can I find the individual trees? Can I separate this data set into various trees? And the way I'm going to do that is to look for treetops. Look for points which are going to be higher than all the other points around them. Maybe not than another one further out, but locally they're kind of at a maximum. Higher. So like, yeah, looking for the treetop of a specific tree. And this is what so again, it's kind of a simplish algorithm that seems to do a fairly good job at finding the treetops. And then I just, so then I'm going to color these points in different colors. Yeah, and then I'm going to assign to all of the green points which are there, oops, hey, interesting. Yep. Yeah, okay, I just missed this. Okay, fine. So all of the other points, I'm going to assign to them the color of the treetop that it's closest to. So it's kind of segmenting all the green dots with a number that depends on what's the closest treetop that it has. So it's kind of like, okay, it's a technical way of trying to segment the various trees apart from each other. And then I take the treetops and then I kind of enlarge them to kind of represent the whole set of points of the tree, not just the treetop itself. And then I remove the points and I get kind of a picture of what the trees look like in that street. So that's one way of going from these set of red dots into really interpreted information. I have so many trees, they have that height and that kind of width. So that's that. And I could go and take a few more minutes very quickly. Yes. again, forgot, of your time. So just to model a building now, a single building, taking this one here, it's not something that's going to work for every building, but it does work decently for simple buildings. And again, I load the data setup, I visualize it, and this is what it looks like. Oops, that's... So you can see the shape of that building actually. Yeah? You can see with your own eyes, but go try and explain that to a machine. So the machine needs to, you need to do something about this. How does it work? Well, first you look at, for every point you look at what's called the set of normals. So if it looks flat, there's actually a direction of this set of points. So you can kind of draw an arrow at every point into the direction where the roof is looking at. And if you do that and actually forget about the direction of those, the position of those points, you just put them on a sphere. So just so the set of direction itself gives you a very clear indication of how the building is oriented. So just with these points in space, I can already figure out, okay, this building is, I can fit a box around it in the correct orientation. And if I can fit a box around it, that's actually already very close to being over, because if I can kind of orient it along the axes and fit a box, as I say, then I can tell to the computer, okay, look at it from the side. I'm going very fast, and I apologize for that. But in a sense, if you manage to fit a box on that building, there's an easy way to basically compute, okay, I see the slice of that building, I'm just going to fill this in with a 3D model. And so that's what this algorithm does. It just fills in with straight lines within this box that it found out. And so you kind of rotate it back to the original coordinates, and you can, for fun, also add the texture that you get with the aerial imagery, and you kind of get a model of the building. So that's all.
On the model on the basis, it seems that it's like a garage or something?
Yes.
And I'm a bit lost. Is this the same information that you showed us for Flanders, or it's from different ones?
No, it is the same. So indeed...
Also the floors, like for example, you know, okay, this is 3 floors, this is 2 floors, this is so on. But then if you can define the floors, then you should also be able to define the furniture.
So we don't see inside buildings.
Are you lying?
Sorry?
Are you lying?
No, that's true.
Suspicious.
No, that's true. It's really light that was reflected by the outer shell of the building. So unless you have a completely glass roof and walls, this thing doesn't know about levels. It does, so you don't see that kind of stuff. You don't see these points. And and here what's seen is, so what I did in the very beginning, I replaced the points on the ground, which were by an algorithm understood as being ground. Instead of being points, I'm going to link them with a surface. And that's what was done here, and that's how you end up seeing this. Actually, there's a hole here because it's not flat, but the building itself, I modeled it flat. That's what you see with this surface here. It's just taking the ground points that it saw, and it actually doesn't see anything beneath this building. It doesn't know whether it continues, whether it's slopey. It's just a filling in of the points from this side of the building to the other side. That's all this shows. And so it's kind of interpolation, but it's actually, I think in this case, the ground goes back up to the building and there's nothing in between. It's just a hole outside of the building. That's all there is. But yeah.
Can you share the notebook?
It's available on GitHub for anyone to do exactly what just happens. So the data set is available as well.
And at the start of the notebook, you download the data, or is it?
Yes, there's one of the first cells that downloads the data. Yes.
Can you check?
Yes. So the data, this is available on rockestate. Well, I mean, you can find stuff on our blog, and it's actually fairly old. Yeah. Here you see exactly this I just shown, and yeah, there's a link to the GitHub thingy, and this GitHub thing also has. For those of you who know what it is, there's a binder, so you don't need to install anything on your computer. You can click on this, and it's going to launch a server for you in the cloud that's going to let you run this entire demo that I just ran without installing anything on your computer, just in your browser for free. So that's pretty cool. Yeah, that's it. Thanks for your attention.